Good morning, grade 7 student. In this session, we're going to review about the respiratory gaseous exchange, as well as we're going to solve the worksheet together and to discuss it. First, we have the gas exchange in the aquatic medium. Remember when we have this experimental procedure, these are the steps of the experiment. So what do they do? First, we put the goldfish in a water enclosure. This is the goldfish. They are placed inside the water enclosure. And then we put the oxygen probe to follow the evolution of oxygen content. We connected to the oximeter. We said that the oximeter, the function or the role of the oximeter is to measure the amount of oxygen gas in the probe or the water enclosure. Also, we have a control measurement. We said the control is without the fish. So what is the role of the control? The control experiment is done to compare and to explain the different experimental results. So from now on, the control experiment, you have to know what is the function of the control. So the control from now on, the control experiment is used, or the role of the control experiment is to compare and to explain the different experimental results. So you have to study this function, okay? So a controlled measurement without the fish also should be done. So we have another water enclosure, but this time without the fish. So one with the fish and one without, and we compare the differences in these two enclosures. And then we have to draw the results on a graph that is shown in document B. Before we move in document B, this is the note that you have to study. This is the first note, that the control tube is used to what? Compare and explain the experimental results, and they are different. That's why we said different experimental results, meaning that the results of the experiment. Also, we said what is the role of the oximeter? It's used to measure the amount of oxygen gas. So here we have two important notes. You have to know what is the role of the oximeter, which is used to compare to measure, the amount of oxygen, and what is the role of the control tube? It's used to compare and explain the different experimental results. Here we have in this graph, we have the variation of what? Of the y-axis. What is on the y? It's the quantity of oxygen in milligram per liter as a function of time in minutes. So here in this experiment, we are moving 30 seconds, so half a minute, 30 seconds, 1 minute and a half, and so on. At the end, we have the 5 minutes. So this experiment is 5 minute duration. So here are the results of the two experiments. So if I have to give the title for this graph, is the variation of the y-axis as a function of the x-axis. What is on the y-axis is the quantity of oxygen in milligram per liter. And what is on the x-axis is the time in minutes. So if I have to give the title of the graph, the title is going to be the variation of the quantity of oxygen in milligram per liter as a function of the time in minutes. Always is the variation of, it's a graph showing the variation of what is found on the y-axis of the y as a function of x. Always is like this. This is the title of the graph. It's always to be like this. Variation of the y as a function of the x. Sure, in the exam, you don't have to write x and y. Y, you have to replace by the quantity of oxygen in milligram per liter. And x on the x-axis is going to be what? At the time in minutes. This is the title. So it's the variation of the quantity of oxygen in milligram per liter as a function of time in minutes. This is the title of the graph. Let's move to the graph itself. Here in the graph, they use the values. For example, this is 9.600, it's 9.6. Here it's 9.4. Here it's 9.2. Also, this is 9.0, so you can put it 9.0 if you want. And then we have to move into 9.0. This is 8.8, and this is 8.6. Okay? So here we move step by step. So as the time increases, we have two different graphs or two different lines in the graph. We have the control experiment, which is the one without the goldfish. So without the goldfish, without the fish. And in the second experiment, we have the one with the fish. So as time increases from 0 to 5 minutes, the amount of oxygen or the quantity of oxygen, it remains the same in the control experiment, while it decreases in the case we have the goldfish. What does this mean? This means that the goldfish, it absorbs or it consumes the oxygen gas. That's why the amount of oxygen, it decreases. So let's have formulate the hypothesis. Hypothesis, maybe the fish absorbs the oxygen gas or it consumes the oxygen gas. Concentration meaning that the quantities of oxygen at the beginning and at the end of the experiment. So at the beginning of the experiment, the concentration of oxygen was 9.2 milligram per liter in both the control and the experiment with fish, while after 5 minutes, the concentration of oxygen is 8.8 milligram per liter with the fish, and it remains constant at 9.2 without the fish. Lime water test. Remember when we talked the last time about the lime water test? Lime water test is done to identify the presence of a special gas. This gas is the carbon dioxide. The lime water is a clear lime water. So the lime water is clear. In the presence of CO2, this lime water, it changed into turbid. This one is turbid, or you can say it's milky or cloudy. All of them, they have the same meaning. So here, whenever we have lime water, whenever it changed to be turbid or milky or cloudy, so all of them, they mean that we have carbon dioxide. So carbon dioxide is detected here. So here we got two beakers, beaker A, beaker B. Both of them, they contain lime water, while the water from the enclosure, the lime water, it's clear here. So it's a clear lime water in the enclosure without the fish. So there is no fish. Clear meaning that there is no carbon dioxide, no CO2, no carbon dioxide. Why? Because we don't have the fish. So there is no release of carbon dioxide. However, beaker B, the lime water here, it's turbid, or you can say it's milky, or you can say it's cloudy. So all of them, they have the same meaning. So here, the lime water is turbid. As you see here, the lime water is turbid, and the enclosure, the water coming from the enclosure with the fish. So here, turbid. So meaning now we have what? We have CO2. So here, we have the fish. So we have CO2. We don't have fish, so there is no release of CO2. So this means that the fish, it releases CO2, and this CO2 turns the lime water to be turbid. Comparing the appearance of the lime water, it's clear in the tube A. So in tube A, the lime water is clear, while the water comes from the enclosure without the fish, yet the appearance of lime water is cloudy, or it's turbid, or it's milky in B, where the water, it comes from the enclosure with the fish. So what is the conclusion here? If we draw out a conclusion, fish, they release CO2, they release carbon dioxide, which makes the lime water to become turbid or milky or cloudy. So here we have two important conclusions to now. First of all, oximeter, whenever the amount is decreasing. So keep this in your mind. Whenever we have the amount is decreasing, okay? Decreasing amount of a gas, for example, decreasing amount. Okay, this is a general rule, and this is an important one, Decreasing amount, so what does this mean? Decreasing amount, meaning that we have what? We have consume of the gas. While if we have increasing amount of the gas, the amount of the gas is increasing, so we have release of the gas. This is an increasing amount, so we have a release of the gas. So whenever the gas is released, the amount of this gas will increase. While whenever we have consume of this gas, this amount will decrease. So when the amount of oxygen decreased in the first experiment in the graph, this means that the fish consumes the oxygen gas or absorbs the oxygen gas. Wherever when the amount of carbon dioxide is increasing, so this means that this gas is released. So from now on, you have to relate these two words. The amount is decreasing, so we have consume of this gas. Where the amount is increasing, So meaning that we have release of this gas. So this is the notes related to the line motor also. Line motor, what is the role of the line motor? Line motor is the test that's used to detect the presence of carbon dioxide. So if we have carbon dioxide, the line motor it becomes milky or cloudy or turbid, whereas if we don't have carbon dioxide, the line motor will remains clear. So this is the importance of the line motor test. Here, let's move to the worksheet that already we saw. We put it the last week, week 23. So here, question number one. In mammals, the main respiratory organ is the lungs. Here I'm going to start our bonus points for this session. In mammals, the main respiratory organ is the lung. As you know that respiration, all of the lessons, they are related to each other. So you have to review all the sessions related to respiration to solve this. So in mammals, the main respiratory organ is the lung. So here I'm going to start our session with the first bonus point, and here we go. This session, the lungs is the respiratory organ. Who can tell me what do we call this type of respiration? Yes, Razan.
Pulmonary respiration.
Excellent, excellent. Thank you, Razan. So the type of respiration is called the pulmonary respiration, since we have the lungs as respiratory organ. So we call it a pulmonary respiration. Type, if we have the trachea as a respiratory organ, what do we call this type of respiration? Who can tell me? If we have the trachea as a respiratory organ, who can tell me what do we call this type of respiration? If we have the trachea as respiratory organ. So let's see. If we have the trachea as a respiratory organ, what do we call this type of respiration? Yes, I want you students. I want you hands. Raising your hands other than Razan. Yes, Lin Khalifi.
Tracheal respiration.
Excellent. Tracheal respiration. Do you know, Lin, where do we have this type of respiration? In which type of animals? Can you tell me?
And fish.
And tracheal respiration. What is the respiratory organ in fish? It's the gills. So no trachea. Tracheas exist where? Which type of animals? Who can tell me? Yes, Laris, can you tell me?
And
And
insects.
insects. Thank you. Thank you, Laris. Thank you, Lean. And insects. So we have trachea and insects. So this is the tracheal respiration. Okay. Who can tell me what the meaning of diffusion? Diffusion. What is diffusion? Who can tell me? What is the definition of diffusion? Yes. Other than Razan, Laris, Lean Khalifa, I need new hands. Razan, Lean, it's okay. They answered the first part. And Laris also. I need new hands. Yes, Huda, what the meaning of diffusion? Can you tell me?
It's the movement of the particles of a substance from a medium of high concentration to
Yes.
a medium of low concentration.
Excellent, excellent, very good, Huda. It's the movement of particles of a substance from a medium of high concentration, where we have high amount of this substance, where they move to a medium containing low amount of this substance. So pay attention about this. We're going to talk about diffusion in this exercise. So inside the lungs, the exchange is done between the atmospheric air, the air in the atmosphere, and the blood. The table below, it shows the composition of the blood which enters and leaves the lungs in man, human. So here we have the quantity of oxygen, and here we have the quantity of carbon dioxide in every 100 milliliter of blood, in the blood entering the lungs and in the blood leaving the lungs. So in the quantity of oxygen, let's start with the quantity of oxygen. First of all, let's clear this. So let's move to the quantity of oxygen. The quantity of oxygen in the blood entering, the quantity of oxygen in the blood entering the lungs, it was 15 milliliter, while the quantity of oxygen in the blood leaving the lungs, which is here, it's 20. So here the amount it is what? Let's move. quantity of carbon dioxide. It was 53 in the blood entering, while it becomes 49 in the blood leaving. So in the table below, compare the composition of the blood which enters the lungs to that which leaves the lung. The composition, what the meaning of this? This means that you have to compare the quantity of oxygen in the blood entering and the blood leaving, and also you have to compare the quantity of carbon dioxide in the blood entering and the blood leaving. So oxygen in the blood entering and the blood leaving should be compared together. Oxygen in the blood entering, blood leaving, and also carbon dioxide should be compared together in the blood entering and the blood leaving. And pay attention, please. We can't compare oxygen and carbon dioxide together. Imagine that you compare oxygen and carbon dioxide. You say we have 5 apples while you have 5 bananas. There is no comparison. Okay, so you have to compare oxygen in the blood entering to that in the blood leaving. You hint in this question comparison. I gave you this hint in the quiz. I want give you this hint. Hint: do you have used the comparison more than or less than? So you have to use these terms: more than, less than, higher or lower. But I prefer to use more than or less than right now. So more than or less than, like in math, for example, 5 is more than 3, let's say, or 3 it's less than 5. So let's start step by step. Zahra, do you have a question or do you want to answer?
No, I want to
To
answer.
answer? Okay, yalla Zahra. Let's start first step. I'm going to clear this writing. And let's start first with the quantity of oxygen. All of you, please pay attention because this is a very important application. Yalla Zahra.
And the quantity of oxygen,
Yes.
the the blood entering the lungs
Yes.
was 15.
15 what? Milliliter.
15
Let's
milliliter,
excellent. Which is
which is more than the blood, less than the blood
less than. Pay
leaving the
attention. Pay
lungs,
attention. It's 15 here and it's 20. So it's less than, which is less than what, ya Zahra?
less than the blood leaving the lungs, which
No, no,
is
no, no.
20
Wait a minute.
milliliter.
Wait a minute. Excellent. You started very good. You started very good. So, Zahra, please stay away from the noise in front of you and let's focus here. Starting first, the quantity of oxygen. You started exactly, all of you, please pay attention to this. So, the quantity of oxygen in the blood entering the lungs, you say it's 15 milliliter. Very good. So, you started with the greatest value or the greatest way. So, this is the top way to start. Excellent, Zahra. Then you have to move. So you said the quantity of oxygen in the blood entering the lungs was 15. Then you have to start to compare, which is less than or greater than. This is the first word. Less than or greater than to 20, 15. What do you think, Zahra? It's less than or greater than?
Less than.
Excellent. Which is less than. Less than what? It's not less than the blood. It's less than the quantity of oxygen in the blood leaving the lungs. So here we are comparing the quantity of oxygen. So the quantity of oxygen in the blood entering, it was 15 milliliter, which is less than the quantity of oxygen in the blood leaving the lungs. Okay, Zahra, you got it?
Yes.
Can you do it again by yourself? All of you, please pay attention to Zahra. Yeah. Yes?
In the
quantity of oxygen, yes?
the quantity of the oxygen, the blood leaving
No,
the lungs,
start in the blood
entering the
yes.
lungs.
It was?
It was 15 milliliter.
Excellent. Which
is less than the quantity of oxygen.
Very good. Where? In the blood,
lungs,
which is?
Leaving the lungs. Yes.
Which
20
is 20 milliliter. Very good. Excellent. That's it. Thank you, Zahra. Let's move to the comparison for the carbon dioxide. Here I need new hands other than Laris, Nil Khalifi. Yes, Ali Basma, go. Let's start Ali Basma. Ali, you have to compare the quantity of carbon dioxide. Let's start.
Okay. The quantity of carbon dioxide in the blood entering the lungs is
What?
53, which is
53
greater
what?
than
Pay
the
attention, Ali.
quantity of
Stop.
carbon dioxide
Stop, Ali. Stop, stop. Yeah.
in
First
blood.
of all, you start the quantity of carbon dioxide in the blood entering the lungs is what? 53 what, ya Ali? What is the unit? What is the unit?
Milliliter.
Very good. You have to mention the unit.
Milliliter.
Yeah, let's start from the beginning. The quantity of
Okay.
carbon dioxide. Yalla, Ali, go.
Yes. The quantity of carbon dioxide in the blood entering the lungs is
Yes.
53 milliliter,
Very
which
good.
is greater than
Very
the
good.
quantity of carbon dioxide in the blood leaving the lungs, which is 49 milliliter.
Excellent. Very good. Excellent, ya Ali. Thank you, Habiba. Very good. So Ali said the quantity of carbon dioxide in the blood entering the lungs. It's what? It's 53 milliliter. Then Ali used the hint here, less than or more than, which is more than the quantity of carbon dioxide in the blood leaving, which is 49 milliliter. Very good, yeah, very good. So here we did the comparison. Some of you is going to do what? And pay attention to this mistake. Some of you is going to compare the quantity of oxygen in the blood entering to the quantity of carbon dioxide in the blood entering. So this comparison is not true. So you have to compare the oxygen with the oxygen and the carbon dioxide with the carbon dioxide entering and leaving. So you can't compare oxygen to carbon dioxide. We can't compare this. So here we solve the first part, which is the comparison. Let's move to the second part, part B. How can you explain the change in the amount of oxygen? Here in the blood entering, the quantity was 15. In the blood leaving the lungs, it was 20. What do you think about the lungs? They are rich in oxygen or they are poor in oxygen? What do you think about this?
Rich.
They are rich in oxygen. And
Rich in
the
oxygen.
blood is going to be poor in oxygen. So Hassan, if I want to say, Hassan Ijradi, that we have diffusion here, we have the process of diffusion. So if the lungs, they are rich in oxygen, these lungs, they are rich in oxygen, okay? And the blood is poor in oxygen. Okay, Hassan Ijradi, do you hear
Yes.
me? Okay, so we say that the oxygen, the lungs, they are rich in oxygen and the blood is poor in oxygen. From where to where the blood diffuse? From where to where? Diffusion will occur from the lungs to the blood or from the blood to the lungs. Remember the definition that Huda said before for the diffusion. Diffusion is the movement of the particles of a substance, is the movement from a medium of high concentration, high amount, to a medium of low concentration, low amount. So what do you think, Hassan? From where to where did the oxygen diffuse? Yes, Hassan?
The blood entering the lungs, it
No, no,
reach in
no, no, no. I want you to say the conclusion. The conclusion is related to diffusion, Hassan. So from where to where did the diffusion occur? From the lungs to the blood or from the blood to the lungs? Can you tell me? Okay, let's have another new student. Thank you, Hassan. Pay attention to this note, Hassan. Let's have another. Let's move to Taline. Taline, what do you think? Taline Zen, what do you think about this?
Yes.
What do you think? The diffusion that occurs from where to where?
um,
It occurs from a medium of high concentration to a medium of low concentration. So from where to where it occurs? Which one is rich in oxygen? The lungs or the blood?
Hassan.
Mm. Taline, do you hear me?
Yes.
What is your answer?
The lungs.
Mm. Okay, let's have Razan. Razan, what do you think? Since Razan was the first
Yes.
one to raise the hand. What do you think? The oxygen will diffuse from where to where? From the lungs to the
From
blood or opposite, from the blood to the lungs?
From the lungs to the blood.
Excellent. Oxygen will diffuse from the lungs to the blood. Why? Because the lungs, they are rich in oxygen and the blood is poor. That's why the amount in the blood leaving, it increases. While Ali Basma, what do you think for the carbon dioxide?
From the blood to the lungs.
Excellent, excellent. Thank you, Razan. Thank you, Ali. Thank you, Talin and Hassan. Okay, so the quantity of oxygen, pay attention to this. The quantity of oxygen in the blood entering the lungs is 15 milliliter, which is less than, here I used a word that is used instead of three words. I used the word that. What the meaning of this? That, it refers to what? That, it refers to three words, to the quantity of oxygen. So instead of saying the quantity of oxygen in the blood entering the lungs is 15 milliliter, which is less than the quantity of oxygen in the blood leaving, I use the word that. That is used for the quantity of oxygen. So instead of saying the quantity of oxygen two times, I can set the word that. So here the quantity of oxygen in the blood entering the lungs is 15 milliliter, which is less than that. What is the meaning of that? That, it refers to the quantity of oxygen. So instead of saying the quantity of oxygen twice, I can say it one. And instead of saying it's the second time, I can say the word that. So that, I use it instead of the quantity of oxygen. So which is less than that in the blood leaving the lungs, which is 20 milliliter. Also, the quantity of carbon dioxide in the blood entering the lungs is 53 milliliter, which is greater than, also I said the word that. That, it refers to what? To the quantity of carbon dioxide in the blood leaving the lungs, which is 49 milliliter. Conclusion, already we studied this before, and if you remember, I gave you these as notes. So oxygen gas, it diffuses from where to where? From the lungs, which is a medium rich in oxygen gas, to the blood, which is a medium poor in oxygen gas. Whereas carbon dioxide diffuses from the blood, which is the medium rich in carbon dioxide, to the lungs, which is a medium poor in carbon dioxide. So here, these are the notes on your copybook that we have, that we write these before us in 2 weeks. So here, oxygen gas diffuses from where to where? From the lungs, with a medium rich in oxygen gas, to the blood, which is a medium poor in oxygen gas. Carbon dioxide, the opposite, from the blood, which is rich, to the lungs, which is medium poor in carbon dioxide. Let's move now to question 2, the second question. Frog respiration. So the frog has two types. Has a pulmonary respiration through the lungs, accompanied by important cutaneous respiration, and the skin is composed of a thin membrane that contains a large network of blood vessels. So here we have a skin that contains large network, a connection of blood vessels. These characteristics allow the gaseous exchange between the blood vessels and the surrounding. It passes winter completely immersed, immobile, we don't move in the air. While, let's move now to the next ideas. Here we have the summer, the frog lives near the mare and gets in water for the smallest warning, but not for a long time. It digs back rapidly. During inspiration, the nostrils open and allowing the air to enter into the mouth. The nostrils then close and the air in the mouth is forced into the lungs. During expiration, which is the exhalation, the air exits from the lungs into the mouth. Finally, the nostrils are open to get rid of the air. In summer, the needs of frog in oxygen, they are 3 times more than that in winter. So the pulmonary respiration ensures 70. So pulmonary respiration gives about 70%. Total it's 100. So 70% is by the pulmonary. So here, according to the given text, sometimes we're going to say pick out from the text. Indicate the 2 types of respiration in the frog, as well as the respiratory organs. So here, the first type, what are the 2 types of respiration mentioned here? I need new hands. I need Fatima Baddah. How many types of respiration do we have? Fatima, do you hear me? Maybe she can't hear me. Let's move to Larissa Skaiki. Larissa, good morning.
Good morning.
So they said we have two types of respiration. Can you tell me what are these two types of respiration? They are mentioned here in the text. The frog has, yes, Larissa?
Lungs.
Type of respiration is the pulmonary respiration, and the organ is the lungs. Second one is called what? Which type of respiration is called? Cutaneous.
Con- continuous
And it's through what? Through the
through the skin.
skin. Very good. So we have two types. Pulmonary through the lungs and cutaneous through the skin. What are the characteristics that favor the gaseous exchange? What are these characteristics? They have a large network of blood vessels. So we have high number of blood vessels. This allows the exchange because the blood carries the oxygen. Name the two phases of respiratory movement. In the respiration, how many type of movement? We have inhalation, exhalation. And first, for part 5, formulate a hypothesis to explain the difference in oxygen need. Maybe in summer, the frog has to do more activity. It's more active. That's why it needs more oxygen gas. So pulmonary and cutaneous respiration here. Pulmonary, what is the organ used? It's the lungs. While in the cutaneous, we have the skin. Okay, the skin is composed of a thin membrane containing a large network of blood vessels, and this allows the exchange. How does the respiration vary? What the meaning of vary? It changes. So the need of oxygen are 3 times more than in summer than in winter. While pulmonary respiration, it gives about 70%. Whenever they said pick out, you don't have to write the whole text. You have to write specific notes in the text. And inhalation and exhalation, they are the respiratory movement. As we said for the hypothesis, it should be logical prediction. So you have to write hypothesis, not then 2 dots or colon. Maybe during summer, it's more active, so it needs more oxygen. So that's why the needs for oxygen in summer, it's more than the need in winter. Why? Because in summer, and you as well, in summer you are more active, you have to do more activity, you have to run, to swim, to play football, to exercise, and this needs more oxygen. That's why during summer it's more active, so it needs more oxygen. This is everything for our session today. Review these exercises because they are very important for our quiz.